This is the Kickstart module for the DTN DevKit. The purpose of this is really to do a little bit of familiarization with the emulation environment that we're going to be using in order to exercise Ion, and then to run through a couple of really simple examples of a scenario and look at sort of what's going on, what's some of the information that we can figure out from Ion about what's happening, so that we can sort of visualize what's going on in Ion and what kinds of decisions it's going to be making and where bundles are. And then we'll do a little bit of executing commands on nodes by hand, and finish up by starting up a different scenario and then pulling some things that are specific to the class. So agenda, just went through this. We'll start core. Core is the Common Open Research Emulator. This is the emulation environment that we're going to be using to run Ion in. What we're going to be trying to do is exercise Ion on multiple nodes so that we can actually do some multi-hop routing. You can configure Ion to run multiple nodes on a single machine and to segregate the areas of virtual memory that, that Ion uses for its functions. It's a little bit easier, at least sometimes, to do that in an environment where the nodes actually sort of look more separate. And one of the other things that Core allows is some relatively easy configuration of the links between nodes, so we can add latency and some arbitrary packet loss and see how those things affect performance. And it's a little bit easier to do that in Core than when everything is running over loopback, and it's a little bit harder to figure out. So we'll start with we'll start with getting the VirtualBox in the on the DevKit machine up and running. So download VirtualBox. You can, if you just Google for VirtualBox, you can download that Oracle VM, and then you can get the new Ubuntu, the DTN DevKit is the machine that we're going to be powering on. So if we go over here, NASA DTN DevKit, and we can just start this. Oh. So this is booting up the, in my case, it's not the ISO image. I've actually gone ahead and installed this down onto into a virtual machine of its own, so that changes are persistent. But when you get things started up, you get a screen that looks like this. You can then go to this terminal and type core-GUI and go ahead and put it in the background. And then you get this canvas that's sitting over here that is this emulation engine. So from there, the next thing to do, and I guess I can go back over here. Okay, so we've got a terminal. We started up Core. We're going to load up the base scenario. In PowerPoint, that's really complicated because it goes through a bunch of screens. If we go over here, it should be a little bit easier. We just say File, Open. It's going to default into Home, Core. There's this hidden directory called .core. Core, unfortunately, is the username in the virtual machine. But then in the user's home directory, there's this hidden directory called .core. And in there's a configs directory. We're going to go ahead and open up the DTN DevKit and the base scenario, and then double click on base.imn, and that'll load us up this. So what this is showing is a number of virtual nodes. So here we've got 4 virtual routers that are sitting here. Each one has got some Ethernet interfaces. So ETH0 on this node 2 up here has an address of 10.0.0.2, and similarly you can walk through the rest of these. The things that are here that are in these sort of purplish bubbles are just pictures. what this is reminding me that the convergence layer that's running between N2 and N1 across that link is a UDP convergence layer. There's a TCP convergence layer running here, and this is LTP running between sort of this ground station and the satellite. But again, those are just sort of ovals that are there for just to remind me what's going on. They don't actually control anything that's in ION. The other bit is this wireless LAN down here. This is the thing that's controlling this wireless link between the ground station that's N3 and the satellite that's over here. We're using a very simple wireless model in Core. Core supports some more complex wireless models, but we're using a very simple distance-based model where if these two nodes are less than some distance apart on the screen, then they're connected and everything's fine. And if they're greater than that distance apart, then they are not connected and everything stops, or connectivity stops between them. So if we take that. And the other thing I didn't mention, when you load this scenario up, nothing is actually running. The virtual nodes are not booted up. You need to hit this green start button in order to start things up. So we'll go ahead and do that. We're going to hit the start button and we'll wait a little bit and see things show up on the screen. So I'm going to go ahead and start this session. This window here is related to the mobility. So this satellite node is going to move back and forth, and really it's doing that so that it connects and then disconnects this link to the ground station. And a lot of these scenarios have some automated stuff show up, like all this group that shows up on the screen that's trying to help you understand what's going on with, in particular, contact graph routing. So a lot of stuff sort of started up all at once here, and I can go through it. This window here is listing the number of bundles that are resident at each node waiting to be forwarded. So right now there are 20 some odd bundles at node 3. That's this node here. They are waiting to go out, and then now the connectivity showed up. Those are pings that are coming from node 2 to node 4. So what happened is when we started this, there's some scripts that get invoked when the scenario starts, and node 2 starts pinging node 4. So we've got this ground station pinging the satellite, and like now everybody's connected, and we have these relatively low round trip times. And when the satellite moves out of range, or when ION thinks it moves out of range, then we lose connectivity. And now what we're seeing up here is bundles are piling up at node 3. So the bundles are being, the ping requests are being sent by node 2. They're getting routed over here to the ground station, and they're having to wait there for the satellite to come back. Now, sort of physically in Core, connectivity has been reestablished. There's a trick to getting the ION schedule and the Core notion of connectivity completely synchronized, and so they're not completely aligned here. And so now what happened is once ION figured out that these things have been reconnected, then we see bundles start to flow again. There's nothing being queued because all the bundles, all the pings are going all the way through and all the way back. If I go over here and scroll, actually I'm going to Control-C this. If I go back here and scroll up, what you see is, here was the last period of connectivity where we had low round trip times, and then after 97, Control-C was probably not the best idea. After node 97, what you saw was a giant pause, and then the ping times went up. I'm going to go ahead and restart this. I can restart it. I just hit the X button there. Everything goes away, and then I can completely restart the scenario. That's one of the things that I like about this for developing scenarios to show off capabilities of ION, is when everything goes horribly sideways, you hit the stop button, restart, and you're in a completely clean space, and ION restarts, and everything starts from sort of a known state. So I'm going to follow this back. Now we can watch it run. So we had a couple of pings get through before the satellite got away, and we have low round trip times. What we're going to see when this comes back is you'll see a whole bunch of, I'll make this window larger so that we can see what's going on. What you'll see is a whole bunch of pings will show back up, in particular probably 22-ish of them. And they'll have large round trip times because all of those pings have been sitting at N3 for several seconds. So we see 21, 25, 20 seconds, and 28, and then they come back down and settle back out. Another thing to notice about this is these are not in order, right? So we got, while things are connected, things tend to flow in order. So we got 2, 3, 4, 5, 6, 7. Here's 15. Here's 8 is way down here. There's 9. If we poke around, here's 11. Somewhere there's 10. So those things don't show back up in order, but now we're going along. We had connectivity, low round trip times, and now the satellite gets away again. And then in a second it'll come back, and we'll see the sort of the same thing repeat itself. This window over here, this is looking at what ION's notion of connectivity is. So in particular in CGR. So what this is showing or trying to show is periods when links are either connected or disconnected. So this is the link between nodes 1 and node 2, from node 1 to node 3, 2 to 1, 3 to 1, and 3 to 4 and 4 to 3 are the satellite that's out here. So what this is saying is nodes between node 1 and node 2, the link is always there. You know, there's always a link. It can send UDP whenever it wants. Between node 1 and node 3, the same thing. And all of these things are bidirectional. So 1 can talk to 2, 2 can talk to 1. You've got connectivity between 1 and 3 and between 3 and 1. And then when you get out here to the satellite, things get interesting. What this is showing, the blue periods are times when there is connectivity, but that's not connected right now. And the white periods are times when there's no connectivity, and this sort of red line that's vertical that goes all the way through everything is the current time. So you saw what happened is this bar turned red when we moved into that period of connectivity. And this is ION's notion of connectivity, which again is slightly different than CORE's notion, just because getting those two things synced up is sort of problematic. So here now we've got connectivity as far as ION is concerned. It's going to go ahead and pump out bundles. And when either this turns back blue or that link goes away, we'll lose it. So this actually, that was pretty good, pretty well synchronized. So we lost that connectivity, and now we're in a period of no connectivity between the spacecraft and the ground station. And we'll come back. I think so. So their core just knows that things are connected well before ION does, and you'll see that no bundles are flowing because ION isn't even going to try to transmit until it thinks that there's connectivity, and then once it does find that connectivity, then it blows all the bundles back out, and here we are. Oh, right. This over here is just another slightly different version of the connectivity. This is sort of the real-time version, where the red links here are things that are currently connected, and you'll see when that satellite goes out of range, this link will turn gray, I think, showing that there either was connectivity in the past or will be connectivity in the future there, but there's not right now. And so the combination of these two is really meant to try to help you understand, help me visualize sort of what's going on in terms of the schedule-aware bundle routing, and understand sort of where ION thinks it should be routing bundles, and go through that and use that to help craft some interesting scenarios. I'm going to go ahead. Well, maybe we can just go ahead and do this. I'm going to go ahead and get here. I'm going to shut down this ping so that it stops doing that. So I will Control C him, and eventually that should go away. And now we can do a couple of things by hand. One of the other nice things about this emulation engine is you can just double click on one of these routers, and it will give you a shell that is locked into that. So if I double click here on N2, what it did is it went over here to the window where I had started the core GUI, and it gave me this terminal, this second tab in that window that is essentially a shell that is on this virtual node. So I can do things, all the things you would normally do in Linux. So I can do like a PSAUX and say, here's all the stuff that's running there. And this is really mostly just the Ion stuff. There's an SSH daemon that's running there to help support some of the graphics stuff like these windows. And we'll go through all of what all this stuff is, right? So there's a TCP and UDP convergence layers. BP echo is the thing that responds to pings. There's a BP receive file that's running just for doing other kinds of testing. And there's some network management stuff there as well that we'll talk about later. But one of the other fun things that you can do with this is running some of the Ion commands. So we can, these are all sort of Linux virtual containers. So this is on node 2, so I'm on this guy here who's got an Ethernet or an IP address of 10.0.02. He's got a peer over here that's got a 10.0.01 IP address, so I can ping 10.0.01 and I get answers back. And this is just regular IP ping, not pinging using bundle protocol. We've got a whole host of other tools available to us as well. So we can do things like run TCP dump. If we double click on somebody like N4, then again back over here it gave me just another tab with a terminal on N4, and I can do things like ifconfig. So this is, he's got a 10.331 address, which is this 10.331 address here. There's this control network that is the sort of the magical back-end network between the host and all of these virtual machines. Again, that's used to support things like SSHing in to show these graphics without having to go over the links that are actually being emulated. So if we go over here to node 4, we can do something like TCP dump -nn -l -i -0 port 1113. Oops. Helps if you can type. So regular TCP dump. There's also Wireshark and T-Shark on the machine. But what this is going to do is just show us port 1113 is the port that's used by LTP. So in a second, now core thinks there's connectivity. Oh, but we're stuck because I only actually scheduled the satellite for a certain number of passes. So while it's moving in and out over here, Ion does not think that it's connected at all again. So I'm going to go ahead and just restart this one more time. If I load all the way, and it'll be good to go ahead and restart it so the ping is actually running and we can see that happening. So I restart it, it comes up. In a minute it's going to give me all of the extra info windows that we're not as interested in anymore. So now if I double click here on node 4, I can get this and do TCP dump -0. So now we're going to watch for LTP traffic. We can look over here and say, okay, we still have connectivity that's coming up, so that's good. And what we expect to see is when this guy gets connected, and once Ion thinks it's connected down here, we'll see a bunch of LTP traffic go back and forth across this link. And there you go. And it's LTP over UDP in the way it's configured here, and it's over port 1113. So that's cool, but not particularly useful because TCP dump's ability to decode LTP is not that great, but we can kill that off. Another thing that you can do is if you can also get a hold of TCP dump by right-clicking on some of these nodes. So if you right-click on N3, you can go down here and run TCP dump on one or the other of his interfaces, but we can also run Wireshark. So if I get down here and run Wireshark on his ETH0 interface, which is the one that's looking towards the satellite, then what we see is some OSPF stuff, which is not particularly interesting to us. And shrink this down a little bit. And then we get a whole bunch of bundles. So these are bundles that are in LTP segments. So we can go through and see this is a bundle from 1.4 to 2.4. 4.1 to 2.4. So this is coming from the satellite back. So this is the ping response. LTP has got its own report segments and report ACK segments. And we can go through and watch the bundle. So here's a ping request going out. And Wireshark knows a lot more about how to decode into bundles. So this we can go down and see, okay, this is Ethernet, there's an IP, there's a UDP datagram. That UDP datagram is carrying LTP. And if we click down into LTP, we can look in the LTP header if you're interested in how LTP works. And we can look down into the data segment for LTP and follow that all the way down into the bundle protocol. And here we can get into, okay, what's in that primary header? So this is the primary block for the bundle, BP version 6. We can go through here and look at all of the source and destination information that is encoded using the IPN naming scheme. And then there are a couple of extensions, and there's a payload block down here. And the payload block has got, I think, probably the PID of the ping process and a timestamp, and then a little bit of payload just to give it something to say. So we can go through and follow those around, and that's very useful at times when you're trying to figure out what's going wrong. Here was a time when I think just reconnected, so we get a whole bunch of bundles that are all getting spit out sort of one after the other, and then the LTP reports come back and things sort of settle out that way. Maybe the last thing for this, I'm going to go ahead and shut that down. Quit without saving. I'm going to kill off this ping. And I'm going to look down here. So we've still got a couple of connectivity periods for the satellite. So what I can do is I can go and start something by hand on the various nodes. Let's see. If I pick, say, N2 and N3, I can double-click here and get a shell that is on that N2 virtual node. I can run over here and get a shell that's on the N3 virtual node. And on N3, I'm going to type BP sync IPN:3.3. And what this is saying is run the BP sync application, which is going to receive bundles, and the EID, the endpoint identifier that I'm going to be receiving on, is 3.3. My node number is 3, and service number is also going to be 3. So I can do that. I can go back over here to the node 2 tab and BP source IPN:3.3, and I'm going to send it test. So that I'm going to source a bundle. BP source doesn't take any source information, source address information. I'm going to send to 3.3, and I'm going to send this bundle called test. And hopefully, oops, really not that huge. And so I didn't get to it in time to watch it get queued up, but here it is received over on node 3. So once you have a scenario that's set up, you can go into the individual nodes and just start executing commands. And we'll do things that way for a couple of, we'll do a couple of other things that way, both in terms of configuring ION, so we can We can configure the nodes with configuration files, or you can go in through the command line interfaces of the various Ion admin programs and use those to configure them. So we'll do both of those later, and also executing commands, sort of one-offs like this, where you want to send a file from somewhere, or start some other either transmission or reception epoch. So you can do those things. So that's it sort of for the kickstart. Sort of walk through the emulation engine and sort of a basic scenario that's going on. The next thing I'll talk about is going to be pulling some scenarios that are specific to the class that we're going to be using, and then we'll go on from there.